Hey you guys, this is Mr. Millings, and in this video we are going to be doing some more advanced Charles Law calculations. So hopefully you've already watched the first video on Charles Law, where we explain the concepts behind Charles Law and we do some basic Charles Law calculations. In this video we are going to be doing some advanced Charles Law calculations, so grab your scientific calculator and let's jump in and take a look at an example problem. In this example problem, it says that hydrogen gas at a temperature of 0 degrees Celsius is pumped into a flexible spherical container with an initial radius of 10.5 centimeters. If the temperature of the gas changes to 140 degrees Celsius, then what will the final volume of the container be in liters? We're going to assume a constant pressure of 1 atmosphere. So if we read this question here, we can see here that we have a gas that has been placed, specifically hydrogen gas, that has been placed in a spherical container. So here's our spherical container, and what we know is that the initial temperature of the gas that is in this container here is 0 degrees Celsius. If we read on, what we also know is that the radius of this spherical container right here is 10.5 centimeters. If we read on, it says if the temperature of the gas changes, so the temperature of the gas is going to change to 140 degrees Celsius, or rather, 140.0 degrees Celsius, then what we're trying to figure out is what will the final volume of this container be in liters. So if we take a look at this question here, we have a gas that's in this little container here. This gas just happens to be hydrogen gas. And we know that the pressure of this gas is remaining constant. The pressure of this gas inside of here is going to be 1 atmosphere. It's going to stay the same. It's not going to change. And what we know is that we have hydrogen gas, or H2 gas, that is inside of this container, and we want to know what's going to happen to the size of this container. In other words, what's going to happen to the volume of the gas that is in this container if its temperature changes from 0 degrees Celsius to 140 degrees Celsius. So hopefully now that this question makes sense, we can tackle this little problem. First of all, if we take a look here, we know that Charles' law states that V1 over T1 equals V2 over T2, that the initial volume of the gas divided by the initial temperature of the gas is going to equal the final volume of the gas divided by the final temperature of the gas. And when we're working with Charles' law formula, we need to make sure that all temperature units are in Kelvin, which we see right here they are not, so we're going to have to convert them. Also, we need to make sure that the volume units are the same before we can plug any numbers into this formula right here. And so if we take a look, we can see that the initial temperature is 0 degrees Celsius. So what is 0 degrees Celsius? How do we figure out the Kelvin temperature here? Well, that is very simple. All we need to do here is take the Celsius temperature, which is 0, and add 273 to it, and that's going to give us 273 K. So T1 is 273 K, and if we do the same thing here, we can quite easily figure out the Kelvin temperature by taking 140.0 and adding 273 to this, and what we're going to end up with is 413 K. So now that we've converted these temperatures to Kelvin, let's see what's happening. What do we know here? And what is it that we're asked to figure out? We're asked to figure out the final volume. So what we're asked to figure out is V2. We want to figure out what V2 is, but we also want to figure out what the volume is in liters. So specifically, we want to figure out the new volume of this container, or the new volume of this gas. Remember, gases take the shape of their container. They also fill their container up. So we want to figure this out in liters. And so what we have to do first is we have to figure out what V1 is in liters Once we figure out what the initial volume is, we can then use this formula right here, the Charles Law formula, to figure out what the final volume of this container is going to be. So how can we figure this out? Well, let's go ahead and start plugging and chugging. If we take a look, we know that the radius is 10.5 centimeters, but we also know that the volume of a sphere is equal to 4/3 times pi times the radius cubed. And so you learned this formula in geometry class, and even if you didn't learn this formula in geometry, you can Google the volume of a sphere, and that's what it's going to be, 4/3 pi r cubed. So if we take a look here, we're going to take 4/3 times pi times the radius, which it tells us is 10.5 centimeters, and we're going to cube this. And so when we put this in our calculator, when we take 4/3 times pi times 10.5 cubed, we are going to end up with 4,849. But if we use three significant figures here, we're going to end up with 4.85 times 10 to the third centimeters cubed as the volume of this sphere. So the initial volume here is going to be 4.85 times 10 to the negative third centimeters cubed, which is the same thing as 4.85 times 10 to the third milliliters. If you remember from an earlier video that you might have watched of mine, we said that 1 centimeter cubed is equal to 1 milliliter. These units are used interchangeably. So if we have this many centimeters cubed, then we have this many milliliters right here. But we want to know the volume in liters. So what we now have to do is take this one step further and do some dimensional analysis. We want to cancel out milliliters, so we'll put that at the bottom. We're going to convert to liters, so we'll put that at the top. And we know that there are 1,000 tiny little milliliters in 1 liter. Right? We know the prefix milli means 1/1000, so there's 1,000 of these small little milliliters in 1 liter. And so when we take 4.85 times 10 to the third and we divide by 1,000, we are going to end up with 4.85 liters. And this is going to be V1. So we had to do all of this work to figure out that V1 is 4.85 liters. So now that we know the initial temperature in Kelvin, we know the final temperature in Kelvin, and we know the initial volume in liters, we can now figure out the final volume in liters using our Charles Law formula. So let's go ahead and do that. If we take a look here, we know that V1 over T1 equals V2 over T2. And so what we can do is we can get rid of these fractions by cross multiplying. If you don't like fractions like I don't, we can cross multiply, and what we'll end up with is V1 times T2 equaling V2 times T1. And we're trying to find what the final volume is. So we're trying to solve for V2. We'll divide both sides by T1. T1's going to cancel. And so the formula that we're going to use to solve this problem is V2 equaling V1 T2 all over T1. So now we can start to plug in these variables. What is V1? It's 4.85 liters. Let me make this look better for you guys. 4.85 liters times T2, which we just figured out is 140.0 degrees Celsius, which is equal to 413 K. So we have 413 K. Let's go ahead and erase this. We have 413 K. And then we're going to divide this by the initial temperature, which, if we take a look, was 273 K. So when we take 4.85 times 413 and then we divide by 273, we are going to end up with 7.34. 7.34, Kelvin cancels with Kelvin, leaving us with liters. and this is going to be the final volume of this container. And so does this answer make sense? Well, if we take a look here, we know that Charles' law states that volume and temperature are directly proportional. If the volume's doubling, it's because the temperature is doubling. If the temperature is cut in half, then the volume is going to cut in half. If we take a look, what's happening to the temperature is going from 273 to 413. So it's increasing by a factor of a little bit less than 2, right? Actually, 2 times this would be 546. So it's not doubling at all, right? So if we take a look, then what should happen to the volume? The volume shouldn't quite double either. And if we take a look, the initial volume here was 4.85 liters, and it's not quite doubling. It's at 7.34 liters, the final volume. So if we take a look at this problem here, what is the final volume of this container going to be? It looks like this container is going to expand as its temperature increases. And so if we make this look slightly bigger than this, then the volume of the gas that will be in this container is going to equal 7.34 liters. So that's kind of an advanced Charles' law calculation. If you like what you see, go ahead and click that little bomb in the bottom right hand corner. That will subscribe you to my channel. And feel free to leave any comments or questions in the comment section down below. And I really hope you guys found this helpful.